In this video, I'm going to go over some basics on quadratic functions and then getting into taking a quadratic function in any form in terms of standard form, vertex form, or something we'll look at factored / root form in class, and trying to find characteristics of that quadratic and then ultimately lead to graphing it. Okay, so we've already kind of talked about quadratic functions in terms of graphing them back when we did our unit on parent functions. So just a quick review about quadratics. The graph is a parabola. The domain is going to be all real numbers, so negative infinity to infinity. The range of the parent quadratic function is going to be 0 to infinity, including 0. We know this has y-axis symmetry. And we hopefully know from our first unit, if a function has y-axis symmetry, it is called an even function. Again, shouldn't surprise you because our highest exponent is an even number, which is a degree of 2. All right, so when we look at these parabolas, you'll notice sometimes they're going to open up and sometimes they're going to open down. That really depends on the value at the very beginning of your quadratic function, all right, that letter A. All right, so we're going to have, I'll show you on the next slide or next page, kind of 3 different ways that could give you these quadratic functions, but all of them are going to have an A value. If it's positive, it will open up. If it's a negative, it opens down. Now, when that happens, you're also going to have the vertex point for both of these is going to be a minimum or a maximum. So depending upon how your parabola looks, that will tell you if your vertex will be a min or a max. Now, there's something called the axis of symmetry, which is on every single one of these parabolas because it has y-axis symmetry. This axis of symmetry will cut or divide the parabola into 2 equal parts. Okay, so it's a vertical line that divides the parabola into 2 equal parts. Now, when it's the parent function, the axis of symmetry is just the y-axis, or x equals 0. But as you're going to see when we do these questions, they're not always going to have x equals 0 or the y-axis as the vertical line that's cutting it in half. So we have to figure out how to find this axis of symmetry. The reason that we do it in math class is because it will allow us to find more points to graph because of that symmetry. So that's why we do it, even though you'll notice that it is a dotted line or a dashed line when you look at these, and that's because it's not technically a part of the quadratic function, right? So it's always going to go through the vertex. All right, and it always represents the in the equation for a vertex form, which we talked about with the first unit on parent functions. It's always going to be that x equals h value. All right, so you just have to think opposite for that. All right, so it will always represent the min, or excuse me, it will always go through the vertex, and for vertex form, it's going to be x equals h. Okay, now for standard form, to find it, it's always going to be x equals the opposite of b over 2a. Now, it's your choice when you do the math. If you'd like to put that negative with the b, that's fine. It doesn't matter. I prefer to find b over 2a and then just make it the opposite at the end. But it's up to you. All right? Now, the vertex is going to be the highest or lowest point on your parabola. So it'll be the min or max. And you can see it here on these. Right there we have the vertex and the vertex, all right? And it's also the point where the axis of symmetry intersects, the parabola. All right, so that's always true. The axis of symmetry will always go through the vertex, okay? When we have standard form, all right, first you're gonna have to do the axis of symmetry. So essentially first you're gonna have to do what we said down there, where you find x equals the opposite of b over 2a, and then you'll get some number, okay? Then you take that number and you plug it into your function. So you do f of that number, right, into your function, and that will give you the y value. So that vertex that vertex here is going to be that number that you got for the x value for the axis of symmetry, and then whatever you get when you plug that back in. Okay, so we'll practice that a bunch, all right? But if you know the axis of symmetry, you already know half of the vertex, right? You know the x value of the vertex. All right, let me show you the 3 different ways you're gonna see these quadratics written. All right, I'll start actually with the second one. This is the one that we use the most with our parent functions. All right, you'll remember we did our transformations in that first unit for that parent quadratic function, where h is your horizontal shift and k is your vertical shift. And then out front is where you're gonna have your stretch or compression. And then potentially if you have a negative, you'll have your reflection. All right, so that's all gonna be there as before. Now the standard form, which we've seen a lot recently with factoring and using the quadratic formula or completing the square, is that it's very simple to find the y-intercept for this, right? Because the y-intercept is always gonna be 0c, or you could just plug in 0 for x, all right? In terms of finding the x-intercepts, you could set it equal to 0, which we will do in one of these now, or in a moment, and on my key for my homework, you'll see that done as well. We're going to use this formula here to find the axis of symmetry, which will then lead us to find the vertex. All right, so I'm going to show you how to find all this stuff in standard form, all right? We talked about the vertex form, and then the factored form, intercept form, root form. That's another way to say this. You could say root form, all right? Again, this one's the easiest to find the x-intercepts because you've already got it fully factored. So you just have to set each of those factors equal to 0. You'll notice a common theme here. A has been in all of these, right? Doesn't matter which one you are looking at, you're going to have A. If you memorize this form, that's great. This will help you find the axis of symmetry that leads to the vertex. But again, if you don't, you can always distribute, or you could end up graphing points that you know and probably figure out the vertex. Okay? All right, so with all that being said, let's do 2 examples. And I'll let you guys try on your own. All right, so let's start with this first one. First thing I notice, it's in vertex form. The next thing I notice is that in front of everything, there is a negative right there. So that tells me that this parabola is going to open down. When A is a negative, your parabola will open down. That will also mean that my vertex is going to be the highest value, or a maximum. All right? Now, this one is the easiest to get the vertex in vertex form, right? The vertex, you're just looking inside here, all right? And I have the opposite of that h value, which is going to be, or I should say the opposite of that -2, which will give me my h of +2. And then my k, which you just pull the sign with it, is going to be 1. The axis of symmetry is always x equals your h, in this case, which is 2. Those will always be the same. I'll repeat that again a ton in class. So this and this should match. If they don't, something is wrong. The y-intercept is a little bit more challenging to get. So to get the y-intercept, I'm going to plug in 0 for x. All right, so -3 times 0 minus 2. Then square that, and then add 1. So I get 0 minus 2, which is -2, squared, which is 4. So that's going to be -12 plus 1, which is -11. Now that is the y-intercept, 0, -11, but I'm not going to be, well, I guess I can barely graph that on here. The last piece of it will be way down there, but you still can barely graph it. That's fine. To find the x-intercepts, I am going to set the function equal to 0. So 0 equals, -3 times x minus 2 squared plus 1. Now, you may not recognize this, but this is essentially how we solved using the square root method in one of our lessons on solving quadratics. So I'm going to move that 1 over to become -1. Then I'm going to divide both sides by that -3, which will be 1/3 equals x minus 2 squared. I'm going to take the square root of both sides. So it's going to be plus or minus the square root of 1/3 equals x minus 2. All right, so I'm going to get x equals, move that minus 2 over, you get positive 2 plus or minus the square root of 1/3. All right, now technically if you wanted to, you could rationalize that, right? Because the square root of 1, because I can do that work right here. The square root of 1 is 1, so it'd be 1 over the square root of 3 times the square root of 3 over the square root of 3, which would become the square root of 3 over 3. So if you wanted to rewrite that, you could write it as 2 plus or minus the square root of 3 over 3. Again, not really that concerned about it. That's not really what we're focused on right now. But that is going to be our x-intercepts. All right, so that's going to be 2 plus the square root of 1/3, comma 0. And the other one is 2 minus the square root of 1/3, comma 0. All right, so 2 x-intercepts here. All right, so let's go ahead and graph. We know that our vertex is 2, comma 1. Our axis of symmetry is going to go through that. So there's my dashed line through it. My x-intercepts, if you need to use a calculator, you can, right? I just looked it up before I started this video. The square root of 1/3 or the square root of 3 over 3 is approximately 0.6. So 2 plus 0.6 is about 2.6. 2 minus 0.6 is about 1.4. All right, so those are my x-intercepts there. All right, and then we do have the y-intercept of 0, negative 11. And because we have the axis of symmetry, that dot is 2 away from my axis of symmetry. So I have another one that's 2 away over here. You'll notice that we don't have anything when x is 3 or x is 1. So you could plug those numbers into x to find the y. I'm going to show you kind of a nice trick in class is that if you go away from the vertex 1 unit to the right or left, doesn't matter. But if you do that, and then if you were to square that 1, you would get 1. But because we have this a value of negative 3, which is opening down, so the 3 means that it's going to be stretched by a value of 3. So I go 1 unit over, and then I would do 1 down to put a point, but I have to multiply that by 3. 2, 3. So this is going to be my points if I were to plug in 1 or 3. If you don't get that on this video, it's okay. I'll show you in class. And again, you can always plug in or go back to the OG points like we did in our first unit. Okay, so there's the graph. Let's go ahead and do the last little characteristics here. The domain we know or should know is all real numbers, so negative infinity to infinity. Now this range, the lowest y value for the range is going to be negative infinity, and the highest y value is going to be positive 1. For increasing, the function is increasing as you move from left to right from negative infinity to 2, and it's decreasing from 2 to positive infinity. The y values are getting smaller. All right, so that's kind of the whole, kind of everything when it's in vertex form. Let's do one more, and then we'll be finished when it's in standard form. All right, first thing I notice, it's in standard form, right? ax squared plus bx plus c. My a value of 2 is a positive, so this parabola will open up. Now the vertex and the axis of symmetry are going to be a little bit longer to find. To find the axis of symmetry, do x equals the opposite of b over 2a, which is the opposite of negative 8 over 2 times 2. Dividing negative 8 divided by 4 is going to be negative 2. The opposite of that is positive 2. So that's the axis of symmetry. To find the vertex, we're going to take that x value and plug it into the function. So do f of 2. All right, so that's going to be 2 squared is 4. 4 times 2 is 8. That's going to be 16. And we get 8 minus 16 is negative 8. Negative 8 plus 6 is negative 2. So my y value for my vertex is negative 2. So 2 comma negative 2. Now the y-intercept is a little bit easier to find for standard form. It's always 0 comma c, which is 0, 6. But if you forget that, you can just plug in 0 for x and you would get 6. To find the x-intercepts, I'm going to try to factor this. So I'm going to set it equal to 0. I notice it does have a GCF of 2, so factor that out. And then I'm thinking of factors of 3. that add to negative 4, which is going to be minus 3 and minus 1, right? Because negative 3 times negative 1 is 3. Negative 3 plus negative 1 is negative 4. You can bring that down that too, but because it doesn't have a variable, I end up not caring about it. I only care about the factors that have a variable. So my x-intercepts are 3 and 1. So 3 and 1. So 1, 0, and 3, 0. All right, we know if it's opening up, I'm going to have a minimum for my vertex. So let's go and graph this. My vertex is 2, negative 2. My x-intercepts are 1, 0, and 3, 0. Y-intercept is 0, 6. Do your axis of symmetry. And then when you do that, you'll notice the y-intercept is 2 units from the axis of symmetry. So on the other side, 2 units will give my other point. And then doing my little trick, 1, 2, 3, that'd be 3 squared is 9, but then times 2 would be 18. That's way off the grid. So all these points, these 5 points, are the only points that I could plot on this particular grid. Okay, so finding the domain, still all real numbers, or negative infinity to infinity. The range, the lowest y value is negative 2. The highest y value will be infinity. It is increasing from 2 to infinity, and it's decreasing from the beginning, so negative infinity to positive 2. All right, guys, so that is it for quadratic functions. Check out the homework, check out the key. There's, I'll say it in class, there's like one part of the homework where I made a mistake, so I updated that on the key, but I'll let you guys know in class as well. All right, come see me if you have any questions. Good luck.